Good. So we want to transition from solving these linear programming problems by a graphical approach to what you refer to as the simplex method. And what the simplex method basically is, if you listen to the video I made, it's okay. It's basically doing the same thing that you do graphically, where when you form um, the feasible region, those vortices, the simplex method is basically you are taking each of those vortices and you are testing them in the profit function. Well, I mean, not the profit function. I mean, the objective function. We always dealing with profits. That's why I end up slipping and saying that, right? So what the simplex method is doing is the exact same thing. It's actually trying each. It's moving from one vortex to the other, and kind of trying it in the objective function. But it's done purely by arithmetic in matrix form, right? And sometimes you don't understand what's going on, but the process works, right? It has been tried, it has been tested, it has been proven that the simplex approach does the same thing as the graphical approach. The advantage of it is that if you have, look at this problem here, look at the force problem here. Do you notice they have three unknowns, x1, x2, and x3? And that's where the graphical approach has its limitations, because if you try to graph this, those are really what we call planes in mathematics. And you are now working in 3 dimensions. Therefore, it's not going to be very simple, right? To identify the feasible region and then getting the vortices and so, because you're now going to have a 3-dimensional something, you know. So I should definitely let me try this one here. X1 plus x2 plus x3 less than 12. Give me 1 second. Let me try that inside of a. Let me try. Give me 1 second. I think I can get Desmos here, right? I changed windows. Can you see me changing windows, or you're not seeing that?
Yes, sir. I'm seeing it.
Let me see. What were the x plus y plus 3z equal to, what was that, 600? 600. You see, it's not able to graph it. It's not able to graph it. It's not able to graph it because it's a plane and this is a 2-dimensional program, right? You see? So you just can't able to graph these 3. Oh, there are programs, I think GeoGebra does planes. Desmos apparently, at least I don't know the program that deep, right? Yeah, I don't know the program that much to know whether it can graph 3Ds, right? 3D functions, right? You get x, y, and z. And what if you have 4 unknowns, x1, x2, x3, and x4? What happens? You see, so no matter what, the graphical approach has its limitations. However, simplex doesn't have that kind of limitation, right? So let's try one. We'll try a simple one. I want to use these applied ones because it will take us through the whole process of forming the inequalities, the objective function, um, the constraints. It will capture everything. And then we'll move over to the simplex approach to see if we can solve it, right? Good. So this one, I'm here at, let me see here. Let me use this. 1 second. We're using number 3 there, this one here, this one here. Number 3 here, right? So it's talking about a farmer having 100 acres of land to plant wheat, corn, and some details about some constraints, you know. Wheat requires 4 hours of labor, $20 of capital. Corn requires 16 hours of labor. That's labor intensive. You need $40 of capital to do it. And they have a cap. He has a cap on how many hours he has available and how much money he has available. So these are the constraints really. And then you get some profit information here. And so you want to know how many acres of each crop was a sheep, okay? I have sheep farmers now too, you know. Girls are farming too, yeah. So we declare our variables. I'm going to use these blank areas here to do the problem, right? So I'll start with let X be the number of acres for, what was it, wheat. Let Y be the number of acres of corn, right? So they should add up to 100 because that's all the land he has. So X plus Y should be less than or equal to 100, no more than that. Mention is made that each acre of wheat requires 4 hours of labor, $20 in terms of, okay, sorry, let me leave the money one second. Let's leave it the hours. 4 hours of labor, and corn needs 16 hours of labor. So, but he only has 800 hours. So we go with 4x plus 16y. That's all the time. If he plants X acre of wheat and Y acre of corn, the cap will be 800, right? And in terms of money, $20 for each acre of wheat and $40 for each acre of corn. And his cap is 2,400. It can't exceed that. And our objective function, P is equals to $80 for each acre of wheat and $100 for each acre of corn, right? So that's our objective function. We want to maximize this, right? Want to maximize that. So we're not going to use the graphical approach. This can be solved using the graphical approach, but we're going to do simplex, right? Good. And I'm not going to do this by hand, right? Gone are those days. So you're with me so far? You got where I got all these inequalities and this thing and so forth. Tell me what's going on. Got it?
Yeah.
Hmm? How many people we have now in the class? What? Only 7? Oh, all right, yeah. So you're answering, you follow how I got these inequalities?
Yes, sir.
Like only to chant in this class. But so I'm going to, let me see where I have this here. I already um I already have these in what you call a simplex calculator. I already have them there, right? So let me erase it. You guys might want to show up on that other screen. Let's see. It's all there. It's all there. But so let's see where it is. Is it here? So I'm switching over, right? Yeah, this is it here, right? All right, so this is a matrix calculator if you want to, if you're interested, this is emat help. That's it, the website, emathelp.net. No problem using it, right? If you don't like it, you can go find another one, right? So I typed in my objective function. You can see it there. You click on maximize. If you don't want to maximize, you want to minimize, you can uh, uncheck that box, right? But remember, the thing is free, so all these advertisements will come up, right? I can't help it. They put in all of these by default. It's on the way you call it big M method. They have other methods too, right? Dual, step, and all kinds of ideas you got. You click down here, two-phase method and all of that. Yeah. And you click calculate, right? I think I already did. So here is my input, right? My objective function is here. I want to maximize it, subject to these constraints, right? Good. So here it is. We introduce what we call slack variables. If you watch my video, you will see that in order to change these inequalities here to equal sign, right? If x plus y is less than 100, then x plus y plus some number, which we will call S1 in this case, we can say, you know what, that's a slack variable. So x plus y plus S1 is equal to 100. Takes up the slack there. Because x plus y is not equal to 100, right? It has to be less than, well, let's say less than or equal to, right? But to introduce the equal sign, you have to put in what we call a slack variable. That's what you see here with all three inequalities here, right? You see it? We put in S1, S2, S3. Some textbooks, some other programs will use, you see some people use R, S, and T, and all kinds of things they do, right? This program happened to like S1, S2, and S3. What are you going to do? Getting it free, you got to take with it, right? Good. So we take this now, and we have to kind of make up what we call, they call it a simplex tableau, right? Or simplex table. Let me use the word table. Let me not try to break our tongues, right? Good. So that's what they did here. Notice the use of the coefficients, right? Notice with Z. Oh, and in the video I sent to you, the Z column or the objective function was at the bottom of the table. This program puts it on top. Doesn't matter, right? Doesn't matter. The one I showed you, the example I showed you in the video, the lecture video, like the objective function was at the bottom, right? So don't, jump up and want to know what's happening. This person simply, when they did the program, put it on top. There's no problem with that. So, okay, notice what numbers they have. They have minus 80, minus 100. So what's happening here? We actually take everything across the equal sign and make it equal to 0. So you have Z minus 80x minus 100y, right? And well, S1, S2, and S3 is, there's no slack variable in the objective function. And it's all equal to 0. In the case of these here, notice x plus y plus S1 equal to 100. Notice you use the coefficients equal 100, and you do the same for the others, right? Good. And you kind of, as of now, you have a situation where S1, S2, and S3 are all 0, right? All 0. So you put them here, don't worry them. We're going to replace them in just a moment. Good. So now comes the process of where you're going to apply simplex now. So basically, you want to get rid of all these negatives where you see in the Z row here. You're trying to get rid of all the negatives there, right? So what do you do first? So you look for what we call the pivot column. And the pivot column is usually the one where you have the highest negative here, right? Or I say the most negative. The most negative. I shouldn't say the highest negative. It's minus 100. So that's a pivot column. What you do now, you take each of those, the solution here, 100, 800, 2400, and divide by the numbers 1, 16, and 40. That's what is done here. See here? Right? I'm not annotating because when I annotate, I can't scroll. So I'm using the cursor on the mouse cursor to go through what's happening, right? So what you look for next is the one with the least ratio, and you see 800 over 16 is 50, and that's the lowest ratio. So you take that row now. That row is what we now refer to as the pivot row. So we had a pivot column, we had a pivot row. And the number 16, where the pivot column and the pivot row coincide, is what we now refer to as the pivot element, right? So what we're going to do now, we're going to try to make that number into a 1. How do we do that? Well, look what I say. Divide the whole row by 16, and you'll get your 1 where you want it, right? Oh, and by the way, another thing that happens is that you are now going to replace S2 with Y. Basically, that's your objective, really, to remove all these S1, S2, and S3. Sometimes it doesn't happen. You end up still having S1 or S3 or S2, but you try to replace them with X, Y, and then there's a Z. Well, if you can get Z there, really good, right? Doesn't always happen in the process. Good. So we have made our pivot number 16, or pivot element 16, into a 1. Our next step now is to make this minus 100, the 1 over this one, and the 40, all of it has to become 0, right? So to do that, you have to make use of what we call row operations. We did see one here where you took this row, the row with, I noticed they call this row 2, right? Sometimes what they're saying here is kind of confusing. They're calling this row 2. Sometimes they might refer to this as row 1, row 2, this is row 3 instead, right? But you will catch up which row they're talking about. So we took this row and divide by 16. So that's really a row operation, right? And that's how you get this row here. This row here. Divide everything by 16. Notice we bring down that Y and you replace S, right? S2. S2 is what they call a leaving variable, right? And it's replaced by Y. So our next step, as I said, is to make the minus 100, the 1 above here, and the 40 all into zeros. How do we do that? Notice the row operation. So they say you take row 3. You see now they're calling it row 3 now. Oh gosh. Down here was row 2, now is row 3. All right. You see, that's the downside of the calculator. It's doing its own thing. So they're taking this row with the Y here, this row. Multiply it by 100 and then adding it to row 1. So you take all these numbers here, multiply it by 100, each of them, and you add it to this row on top here. Right? Sorry, down here. Take this row, multiply it by 100, and then add it to this row here. This is what you'll get. Right? You'll get minus 55. You get 0, 0, 25 over 4, 0, 5,000. Right? Good. Now you have your 0 there. Now you have to make this one here into a 0. And you have to make this 40 into a 0. And I don't want to bore you with these are the steps you. But guys, to make this one 0 now, look what you do. You subtract row 3 from row 2. You take this row 3 here, subtract it from this row, or you take this one, subtract it from this, you will get this here. And your objective was to make this into a 0. And it happened. Right? And next you want to make this 40 here, this 40, into a 0. What do? Notice the row operation again. Right? You take row 4 and you minus 40 times row 3. Right? Take this row here, multiply it by 40 and subtract it from this row. And you will get these numbers here. Right? When you watch back this video, what you could do is stop the video and try it by hand. Right? But of course, you don't have to worry yourself. The calculator did it all for you. However, I could very well ask you in a test, how do you make this number here, 40, into a 0? I can ask you that. What row operation? And I give you some options. So you have to know how to do it. So even though you have a calculator, you have to know, what do I do to some row to, to make that 40 into a 0, right? So here it is. They went through that. Now you have to repeat this whole process. So you finish with this whole column here. Only this one is non-zero, right? All the others is 0. That's your objective. Next step now is to look for another negative now, the most negative in the Z row here. And you see minus 55. And I'm not going to repeat the process. We're going to repeat that same procedure I showed you just now, right? Repeat the same procedure, right? We're going to take this as the pivot column, right? Then you're going to divide each of these values, the 50, the 50, the 400, by these numbers, 3/4, 1/4, 10. Look at the ratio at the end here. Which one is the smallest, right? And the smallest is 40, right? So what you're going to do, you're going to replace S3 with X, right? And 10 is going to become your, what we call the pivot element, and you're going to make everything above that, and you're going to make that 1 first of all, and everything above it 0, right? And this is the process here. You divide that last row by 10, it becomes 1, very nice. You have to now make this quarter, this 3/4, and the minus 55 into zeros, and this is the procedure here. This is the row operation. I'm not going to go through it, right? Then that's the next row operation. And then finally, let me give it a minute for you to watch. And then finally, you get rid of the top row where it has, not the top row, this row here, this quarter that you see here. You get rid of that and make it into a 0. And voila, everything is 0 above it. All right? So you have a third thing to go through now. Notice there's another, yes, there's another number here. S2 is minus 15/2. You repeat the same procedure again. Identify, yes, the pivot column. You do the division, then you do the pivot row. Notice a little funny thing here. Don't worry, the negative. Right? Ignore it, but the smallest ratio is 160. That makes 1/8, the pivot number or element. And you repeat the procedure where you try to make that into a 1 and everything else above and below it into a 0 using row operations. And that's what you're seeing here. Actually. Yeah. So you try to make everything above it 0. So you see they make that into a 0 using row operation. Then you make the 1/8 into a 0. You make this minus 1/4 into a 0. And this is everything here. So when you look in the Z row now, there's no minus sign. What that tells you then is that you have actually reached the optimum condition, right? Where Z takes on its maximum. And here it is, they have the solution, right? Solution is Z is 8400. That's the optimum solution, right? Or the optimum value for the profit function. And it occurs when, notice, X equal 80, Y equal 20, or the S2. Those were slack variables, right? So if you were to plant 80 acres of wheat and 20 acres of corn, you're going to achieve the maximum profit given the constraints that were given, in terms of labor and money, right? What should come out here is that for you to do this process by hand, right? I mean, this problem could have been easily solved with a graphical approach. But I wanted to use the simplex. It's much, much more difficult to use the simplex when you just have two unknowns. It is better to go and use the graphical approach and done. But I just wanted to introduce you to the simplex method and show you that, well, there are calculators that are out there that will do the job for you. However, you must know the process, right? You must understand how you pick out the pivot row, pivot column, how you pick out the pivot element. What do you do with the pivot element? What do you do after that? What are row operations and how to do row operations? There's no rule where you tell you, that do this in the next step and do that in the next step, right? You got to understand, well, what do I do to make this entire row here, the number in front of above the pivot element 0, and the number below the pivot element 0. How do you do that? What row operation must I do? You have to figure that out on your own, right? But when you watch, if you watch a number of them, these examples, you're gonna figure it out, right? Like down here, X, right? Look here. Let me just show you. So X down here, where is that? Yeah, down here, S2. This is a 1. And you get a minus a quarter here. You want to get rid of this and make it into a 0. What do you do? All right, notice what they say. You take row 4, that's this row here, divided by 4. No, what is it? You take row 2, that's this row here, right? This row. Take row 2, divided by 4, and add it to this. And you see what happens. If you take 1 and divide it by 4, it will become a quarter, right? But you do it for every element. But I'm just concentrating on this one, right? So you take 1, you divide it by 4, you get a quarter. Quarter plus a quarter will give you 0. And that's what they did here. They did it for every element, right? You just don't do it for this one. But you are looking at this particular element, this minus a quarter and this 1. What do you do to 1, right? That when you add it to minus a quarter, it will become 0. That's what the question you need to ask. And whatever operation that is, you do it to every element here, right? And here. Not just to the 1 and the minus a quarter, to everything in the 2 rows. Right? Take some time and watch what the people do. Good. So let's try one now. We have done this one where it's 2 unknowns. Let's go to one that involves 3 unknowns. And definitely, you can't say, man, best I do the graph for this thing and all. No. Right? You have to use simplex. So let me go back to here. Good. So, okay, that's this one here. Question 4. Are you seeing question 4? I will annotate here because I could erase this one.
Yes, sir.
Everybody see question 4. So
Yes, sir.
factory manufactures chairs, tables, bookcases, and they use uh, 3 operations: cutting, assembly, finishing. So there's some constraints on each, the amount of time that you can spend on each operation. So mention is made that the first operation can exceed 600 hours. That's cutting. Second operation, that's assembly, can't exceed 500 hours. And finishing can't exceed 300 hours. And they give you a breakdown now how long chairs take for cutting, for assembly, for finishing, how long tables take for cutting, finishing, assembling and finishing, and same thing for the bookcase. They give you that. And they even give you some profit information, right? It's all there. So let me use the space. Use the space on top here. Yeah, I'm using the space on top here. I'm going to write the and by now you have to get the knack of how to form these inequalities and so, right? You've been doing this for this is what? Third week, you have to say. I had 1 week with graphical approach. I gave you the videos. Then we did tutorials. Yeah, this is about the third week we enter in here. Huh? Can't remember clearly. But you should know how to make them up. So I'm going to write them here and leave you to bust your brain as to where I got them from. All right. So what are they? X plus Y plus 3Z is less than 600, right? Oh, I forgot the main thing. Wait, what am I doing? I have to declare what's X, Y, and Z. Let X be number of chairs, right? Let Y be the number of, what's it, chair tables. And let Z be the number of book cases, right? So I write the inequalities over here. X plus Y plus 3Z less than 600. And our objective function, I'll write it here. P equal right? That's your objective function. And please take some time to figure out where I got these inequalities from, right? I'll probably tell you one. The first one has to do with the number of hours available for cutting. Notice the information says chairs require 1 hour of cutting. Tables require 1 hour of cutting as well. And bookcases require 3 hours of cutting. So if you make X chairs, right, then 1X is the number of hours that you will take for cutting chairs, right? If you make Y tables, well then 1Y will tell you how many hours you will spend on tables cutting, right? And then if you take 3 hours for bookcase for cutting and you make Z bookcases, then 3Z is the number of hours you will spend cutting table bookcases. When you add all up, there is a cap. You can't exceed 600, right? And similarly, you go and you formulate the other inequalities, right? The profit one shouldn't be difficult for you because they tell you the kind of profit. You make $20 on a chair, $30 on a table, and $25 on a bookcase. right? Yeah. So now what I'm going to do, I'm going to go over to the Simplex calculator now, right? But let me erase all this stuff. All right, so take a moment if you want to write them down or what. But they'll be over there. They'll be over on the what am I saying? It's over on the Simplex calculator. All the information is captured. I have to erase it because when I move over there, this will block up the window, right? So let me see, where's this? Is it there? No. Nope. Oh yeah, this is it here, right? So here we have our objective function. All the constraints are there. So everything is there. And we calculate, right? So they put it all together here, right? It's all here. And we're ready to use the calculator, right? So the calculator is doing its work. So we make up our tableau, our table, right? We introduce our slack variables, S1, S2, S3. Put them in there, 1, 2, 3, XYZ, S1, S2, S1, S3, all of them, everything in there. And we start the process now. We identify which is the most negative number, minus 30. So that's our pivot column. Then you take 600, 500, and 300, divide by all these numbers, 1, 2, and 1. The smallest of them is the 250. That identifies our pivot row. And 2, this 2 here becomes our, we call it pivot element. We have to make that into a 1 by doing what? By dividing the entire row by 2. That's what they did here, right? So where S2 is, right? Where S2, you well, of course, oh, by the way, this Y takes the place of the S2, right? As we see happening here, right? And now we have 1 here. The whole process from here onwards to make this one, this minus 30, and this one, that make them into zeros using row operation, right? So starting with, all right, that minus 30, you see there? See this minus 30? Let's see if we can get a 0 there. How do we do it? Notice what they see. Take your pivot row, multiply it by 30, and add it to this row 1. Right? See what I tell you? Multiply this row by 30. You're always using the pivot row to do something to it, right? And then add it to another row to get rid of all the non-zero numbers. That's basically, you should have gotten that by now. So you do that, and well, that's what happens here, right? You see the minus 30 gone, and you have these numbers. So that's what you want. Next, you have to see this one here and this one at the bottom. Those two got to be made into zeros. And the row operations are right here, right? So here is, they make that into a 0. And to make this one into a 0, and you do these row operations, and you notice you have your 0 here. So in this row, in this column, sorry, only this one is non-zero. Everything else is 0. That's your objective. You have to repeat this process, you know. Look at your Z row and see which one is most negative. You don't see is the minus 10. So that's your pivot row, identify your pivot column. Sorry, that's your pivot column. You do your division, you divide the solution by these numbers here. You see 100 is the lowest. So this will identify your pivot row now. The two intersect at this half here. You will replace this S3 with Z, and you have to make this half into a 1, and all the numbers above it into 0, right? And that's the process here, right? See, you make it into a 1. You replace S3 with Z. So now the whole process to make -10, 5 over 2, and half into 0. So they're doing it one by one. Then they make Z into 0 using this row operation. Then you make this into 0, right? And your objective is to make this half as well into 0, right? That's what they did. When you look in the Z row here, there's no negative now. That means you have reached your optimum conditions, right? The solution has reached its optimum value. So notice 8,500 will be your maximum, and it will occur when Y is 200 and Z is 100. Notice there's no X. There's no X here, right? There's no X. Therefore, they're basically telling you that you can make a maximum profit of 8,500, right? But you have to produce no chairs, 200 tables, and 100 bookcases. That will give you a maximum profit, right? However, the reality of business is that if you're manufacturing table, chair, and bookcases, right? You will know that sometimes, remember, this is what the maths is telling you. But remember, you are making these three things, right? You have to consider other things. Like, for example, you're making tables and selling table only. People will say, why with the chair there, right? So while these numbers, 200 tables and 100 bookcases will give you maximum profit, it's not always about maximum profit. You have to understand, people say, man, you can't sell table alone. You got to get a couple of chairs with the table. I don't know if you understand what I mean, right? You understand? Secondly, you have workers who might be there. They used to cut and assemble and finish chairs. Now, what you do with those workers? You send them home? You understand? So you have to consider this is just what the mathematics is telling you, but you got to think of the reality of the situation, right? So you might say, man, we might have to sacrifice a little bit of profit to satisfy customer demands, right? So you almost use sense. Don't say Simplex say we must make cheer, and that's what we're gonna do, right? Keep that in mind. Good. One last thing before we close, right? What about minimization problems? Give me 1 second. Let me see if I can go back here. Going to taking long. Good. Now, when it comes to minimization problems using Simplex, things get marginally more complicated. And therefore, the best method that I see for you to be able to do any minimization problem is to do this. Use what they call, I'll just scroll down quickly to something, right? Because I know I'm dazzling your eyes. Use what we call the duality principle. What the hell is that? It says the objective function of the minimization problem reaches its minimum if and only if the objective function of its dual reaches its maximum. And when they do, they are equal. What's that now? It's telling you that you transform this minimization problem into a maximization problem. And we know how to solve maximization problem. We've been doing it all week, right? So let's do an example, right? So look here. I'm not going to an actual applied problem, right? I'm just saying, okay, you have some conditions here. You have to minimize z equal 12x1 plus 16x2. And that's subject to these constraints here. Notice they ain't got less than an equal sign here. Actually greater than, greater than. You notice that? So what you do, you take this and you formalize a matrix. You form a matrix, right? So notice you take the 1 and the 2 and the 14, and the 1, 1, and then 13. Put the 12 and the 16 and put a 0 here, right? Good. So when you do that, take the transpose of this matrix. Take the transpose of it. Here it is. The matrix is transposed here. Take this now and form a set of inequalities and a maximization problem, really, right? So look what happens here. The z function becomes 14y. Notice you're not using x anymore, right? 40y1 plus 30y2. Right? So that's 40 come from here, 30. Kind of switch around. Subject to, notice, y1 plus y2 equal is less than 12. Right? 2y1 plus y2 is less than 16. And we know how to solve this. We know how to solve this. Right? And when we solve it using simplex, we will get the answer. Right? We will get the answer. I'll show you in just a moment. Let me see if they solve it here. So you solve it, and the answer is 2010, right? X1 equal 20, Y1 equal, sorry, X1 equal 20, X2 equal 10, and the minimum is 400, right? Let's go to simplex and see what happens. See what I have that here. Look here, right? No, this is they're actually doing the minimum. I don't want you to get into the minimum using, yeah. Let me go to, all right, let me, what did I do with the solution? I had it here, but 1 second, I have to get rid of some stuff. Is this it there? No. Let me write down the constraint and I'll change it here. What were they? What were they? A second. Z equals, not Z. Z equals 40y1 plus 30y2. Y1 plus y2 is less than 12. 2y1 plus y2 less than 16. And well, the non-negativity ones are there, right? And you don't normally have to put that in. I'm not going to use y1 and y2. I'm going to use x and y, right? So I come here. Where is this thing? All right, let me go right here. So my objective function is 40. Now here is 30. I want to maximize what? X plus y must be borrow less than sign. 1 second. Take some doing it. These things take some doing. Copy it, format here. Is that it? Yeah, there's that thing. Yeah. Less than 12, x plus, what is it? 2x plus y less than 16. Good. So we're going to maximize our calculus. Good. So here it is. I'm not going to go through the steps also, right? So our answer here, we go on straight on to the answer. Something is wrong there. We have 400, but it got 4 and 8. Wasn't it 10 and something? Was it 4 and 8? Let me go back and see what the answer. 20 and 10. Oh man, that's using that method. Yeah, 4 and 8. Look here. 4 and 8, yes. Reaches its maximum at 4 and 8, and 400 is the maximum. Yeah. Or a little bit on top. So what you do, you transform. Go back when you go back here. This is what you do. You have a minimization problem. Form this matrix, find the transpose, take the transpose now and make a maximization problem. Take it into Simplex calculator and let it do the job for you. And the solution you get for the maximization problem is really the solution of the minimization problem. Right? It's a miracle of arithmetic and matrices. Right? I shouldn't use the word miracle. Right? The mathematics. Good. So yeah, I'll make this video available so you can always watch it back, right? Um, but the next time we meet is when the test is going to happen. 14th, that's next week, Saturday, right? You're going to have that test. I'm going to give you the times and so. I'll have more than one test because the group is so large. Yeah. All right. Let's stop there.